Picture an AI that can sound more and more anxious just by turning a mathematical dial. Turn the intensity up and its responses can start showing more of the patterns we associate with anxiety. And no, this isn't just some sci-fi idea. It's being developed right now as part of Stellar, a 2-year, $4 million research project involving NYU, the University of Pennsylvania, and the Linguistic Data Consortium. And here's the really interesting part. They're not simply telling the AI, hey, act anxious, using a piece of math called a conceptor to steer what's happening inside the model. So how does that actually work, and why could this matter for mental health training? Let's get into it. Before we dive into the details, let's look at the core idea here, the digital twin. Simply put, it's a computer model that uses real data to mirror a real-world object, think jet engines or entire cities. But when this concept is applied to mental health, it usually hits a wall. Past approaches typically faced one of two limitations. They either relied on rigid scripts which felt artificial, or they were precise copies of a single patient, lacking the diversity of human experience. The program we're exploring today, called Stellar, breaks that mold. Instead of just giving the AI a script, it uses real data to build a digital twin with traits like anxiety levels that can be dialed up or down. It's changing how the AI thinks from the inside, allowing it to show different emotional states instantly. So, how do you actually turn something as abstract as anxiety into a dial you can adjust? The researchers did it by using something called a conceptor. To understand how it works, imagine the AI's brain as a massive web of complex math. Instead of rewriting the entire model, researchers can identify patterns inside that web that are linked to a particular concept. A conceptor can then be used to steer those patterns. Think of it like a huge mixing board in a recording studio. You don't need to re-record the whole song just because you want the guitar a little louder. You just adjust the guitar channel. Conceptors are kind of doing something like that inside the model. And that's very different from simply typing, act anxious. A prompt is basically a request. The AI might follow it really well, or it might give you something that just sounds like anxiety on the surface. A conceptor works deeper inside the model, steering its internal representations as it generates a response. Now, one important distinction here, the AI isn't actually feeling anxious. It's not sitting there thinking, oh no, I'm really stressed right now. What's changing is the pattern of its output, the words, responses, and behaviors that can make it look and sound more like an anxious clinical presentation. And that raises another big question. If you want the AI to sound realistic, where does it learn what real anxiety actually looks and sounds like? Well, you can't just teach it from a medical textbook, because people don't talk like textbooks. A doctor might use a term like hyperventilation, but someone experiencing intense fear might say something like, I feel like my chest is collapsing. They're describing the same thing, but to make a digital twin feel human, it's that raw, lived experience that really counts. Past findings also show that when people are in a state of panic, they tend to focus entirely on themselves, using words like I and me, and their sentences become short and repetitive as their brain shifts into survival mode. By feeding these real-world patterns into the model, the researchers can ensure that when they turn that anxiety dial up, the change in the AI's behavior feels genuinely, unsettlingly real. Now here's where things get genuinely strange. What happens when you don't have just one symptom? What if you want to simulate anxiety and depression at the same time? You might assume these two states, one high energy and restless, the other low energy and exhausted, would just cancel each other out or blur into a lukewarm middle ground. But that's not necessarily what happens. Think about two colored spotlights. If you shine a red light and a blue light onto the same spot, you're not making the red one disappear. They're both still there. Conceptors can work somewhat like this because different patterns inside the model can be overlapped with each other, and that could be really useful for mental health training. Because real people aren't always neatly divided into categories. Someone might be dealing with intense worries and racing thoughts while also struggling with very low energy and motivation. Those experiences can exist at the same time. So a digital patient shouldn't necessarily have to fit into one simple box. Researchers can potentially combine different symptom dimensions to create more complicated clinical presentations. So why build all of this? Why spend years turning feelings into math? The big reason is training. Trainees don't always get the chance to practice with people who have unusual or complicated combinations of symptoms, and that's a problem. Because you can study mental health from textbooks, You can memorize diagnostic criteria, but eventually you have to sit across from an actual person and have a conversation. Stellar is trying to give trainees another place to practice those conversations first, with AI-based digital patients that can simulate a wider range of clinical presentations. Researchers base these digital patients on real clinical data and lived experiences to ground the simulations. The goal is for the digital patient to feel less like, "Hello, I am patient with anxiety, here are my symptoms," and more like an actual complicated human being. And honestly, that's probably the most fascinating part of this whole project, because we're used to thinking about emotions as something deeply personal, something messy, something that's difficult to measure. But now, researchers are trying to turn some of the patterns associated with those experiences into something they can model, adjust, and study. And that leaves us with a pretty big question. Are we actually capturing something about what fear feels like? Or are we just getting really, really good at copying the way humans talk and behave when they're afraid? I'd love to hear what you think. Drop your thoughts in the comments below. And if you enjoyed this deep dive into the strange intersection of AI and mental health, don't forget to subscribe for more. Thanks for watching.